a champion windsurfer, you need strong arms, quick feet, a good board, and awesome wind. Corwin Hardham is a champion. Corwin surfs in the Columbia River Gorge just east of Portland, where the wind never stops. Corwin has been windsurfing since the age of 8, racing competitively since 1985, and he is consistently a top finisher in national competitions. But Corwin is always trying to go faster. That's one of the reasons he has been developing his own design for the fin of his windsurfing board.
I just couldn't find a fin that really fit my needs. I had designs that I'd made before, a couple of years prior to this, that I'd liked, and nobody had made them before. And simply, I just came into contact with the Benson engineering classes, and I didn't see any reason why I couldn't make my own and make them a lot better than everybody else has so far.
Corwin began his dream in this drafting class at Portland's Benson High School. By using the computer-aided design, or CAD, capabilities of the computer, Corwin began by first designing how he wanted the fin to look. With the design now completed, the fin is one step closer to the water.
My drafting class, of course, taught me how to actually draw the fin onto the computer. And of course, once the fin is drawn on the computer, that's how you're able to define the surface for the milling machine to work. In other words, for the milling machine to actually mill out the design, it needs a surface or a design pattern on which to go from.
Computer-aided manufacturing was the next step in the building of Corwin's fin. A file is created using CAD key. This is then converted using Mastercam on the computers in the Benson manufacturing department.
Most people mill the fins by hand, and it's almost impossible to mill a laminar flow foil by hand because there's what a laminar flow foil actually is. It's like a little recurve at the back of the fin, which creates a low pressure area at the back of the fin, which attaches to the flow. And for anyone else to grind that by hand, like people have traditionally done, it's extremely difficult, if not impossible. So on the CNC machine, I'm able to make that extremely accurately, and it's been a really big advantage because nobody's done it so far. It's going to be, my fins are going to be completely different, and if they work, they're completely revolutionary, definitely.
Once Corwin was satisfied his design could actually be made, the data was transferred to the machine that will do the actual cutting, using a special language known as Computer Numerical Control, or CNC.
I would like to try and build the best fins in the world. I can see that with the amount of input I have from professional board shapers and my own experience, and definitely with the machinery we have here at Benson, I see no reason why I can't make the best fins in the world.
With a completed mold in hand, Corwin moves on to Benson's plastic department. The special resins are layered and the mold is pressed together and heated to 400 degrees for an hour. The fin is sanded, and this one gets a customized airbrush design from Corwin's friend, Nathaniel Aiken, in Benson's industrial design shop. Corwin is already well known for his windsurfing ability, but he is also fast becoming known for his talents as a fin designer too, thanks in no small measure to the opportunities that he received right here at Benson High School.
No, the shop teachers here are just incredibly talented. I mean, some of the most, probably some of the best guys in the industry in the science, even in the science parts and in the engineering, drafting, building, and all the shops have just incredibly talented teachers. I mean, there's nothing else like it.